Okay, before we get into the video, I want to tell you a little bit how I made my project. Some of the signs, make sure you can see it, have a little leaf in the corner, and those represent life, new life forms. And then some of them have skull and crossbones, which represent mass extinctions. I did color code the months of the year. The months are blue, and then we have when Earth turns a billion years old, it'll turn like 1 billion, 2 billion, 3 billion. I have those as yellow cardstock paper. And then to get all of the distances for each event, I used the Excel file, and I literally took a tape measure and walked all the way down the field and spaced them out with the tape measure. Today I will be showing you my cosmic calendar. A cosmic calendar is basically the span of 12 months, but it shows us the evolution of our planet, and the smaller time scale will help us understand it a little bit better. Going over the cosmic calendar and the events will help us comprehend the timeline, and it's over 200 meters long. Here we are. We're starting at the 200 meters, and we're gonna go back all the way to the first, or December 31st. Starting at January 1st on our calendar, which is 4,600 million years ago, we have the formation of Earth, and you can see it was all hot molten lava and just kind of rocks. And the formation of the Earth happened out of a mixture of dust and gas around a new sun in our solar system, which that dust and gas were then pulled together through gravity, and the particles allowed a collision, and that created our Earth. This way. We move to January 2nd, we have the formation of the Earth's core, which took place 4,420 million years ago. And I chose to put this in my calendar because without the Earth's core, the Earth would not have survived as long as we have. We can categorize this time from the formation of the Earth to about 4 billion years ago as the Hadean period. So this, basically, we're in the Hadean period, kind of like Hades. They're not like bunch of lava, hot fire going on. But since we're just getting the Earth's core, that means the Earth did not have a core on January 1st. Kind of crazy, right? All right. Here we are on January 17th. We have the formation of the moon, which is 4,400 million years ago. And we're about 191 meters from the end, since our calendar is a full 200 meters long. So we're slowly getting back to the beginning of the 0 meter mark. And we're only about 2 weeks into our cosmic calendar, and we have the formation of the moon. Okay, we're at January 25th. The crust of the Earth is beginning to solidify. We're at 4,300 million years ago, and January 25th. This is when the crust started to solidify due to the molten rock cooling. Since we all had lava, only lava, now it's cooling, so it's getting a little crystallized. At January 29th, impacts are delivering simple organic materials. So all these asteroids are coming and hitting the Earth, and on those asteroids there's different organic materials that are then being put onto Earth. We are at 4,250 million years ago, which is 4 days after the crust has begun solidifying on our calendar. Okay, here we are on February 1st. This event takes place on February 2nd, but it is when rain filled our oceans. So before this, we had no water, basically. And if we talk about raining, like biblical rains, they say that it rained for 40 days and 40 nights, which sounds impossible. But on this event, 4.2 billion years ago, heavy rainstorms lasted over millions of years, which basically filled our oceans and gave us the water that we have today. The rain came out of the atmosphere, which was then water vapor, and it came from comets and volcanoes, which then condensed into liquid rain. But since we have our cooled temperature on the earth, since our crust solidified, the rain did not evaporate. It was still there, so we still have, therefore we have our oceans. All right, we're gonna move on down. On February 15th, we have the oldest known rock, which is about 4,030 million years ago. On February 15th, the rock pictured is actually a piece of Earth's crust, and it was found in Australia. Okay, we're gonna move on to February 22nd. We have the heavy bombardment of asteroids ending. So if we remember all the way in the beginning of our calendar, we had asteroids and comets bringing organic materials to the Earth. Well, here that kind of ends or slows down a little bit. We're at 3,950 million years ago, which is also like 3.9 billion years ago. And if we go a little bit farther, we are at March 1st. And then on March 2nd, we have the earliest evidence of life. As you can see, we have a little leaf at the corner marking some type of life on our planet. We're about 3,850 million years ago. And the chemical evidence is more so like microorganisms. We're not seeing like living beings or really much bacteria. It's just very simple chemical evidence of some type of life. We are on March 17th, kind of in the middle of March. The sun is at 80% of its current brightness. We're at 3,650 million years ago, which is about 3.65 billion years ago. I chose to put this event on my cosmic calendar because without the sun being as bright as it is, we would not have any life support. And we're gonna move on. Okay. We are March 21st, only a few days later, and the Earth is 1 billion years old already. And this is about spring equinox on our normal day-to-day calendar. We have our oldest fossils, finally. 3.5 billion years ago or 3,500 million years ago. These fossils include stromatolites, which are single-cell organisms. And knowing that Earth started to have single-cell organisms at this time, we can start to wonder, what are the other planets doing? Are they just hanging out in space, not doing anything? Well, if we look at Mars, we can see that it was lacking surface water and oceans because they did not have their biblical rains, or so to say, 40 days. We had millions of years of rain. So, Mars did not have that. Therefore, we can know that Mars's atmosphere and the environment was very harsh and had extreme temperature swings, and only being able to support sparse, specialized ecosystems at this time. But here we are on Earth with our oldest fossils. And then, okay, so after our oldest fossils, we have April 1st, which is nothing going on inside the month, but we are 3.4 billion years ago at this mark. Then we have May 1st, which is 3 billion years ago. So we're jumping a big time period, but within those billions of years, nothing much is going on. Okay, then we're gonna go all the way to May 8th. We have the oldest record of the Earth's magnetic field, 3,000 million years ago. And about 2 months and a week after the oldest fossils have been recorded, the magnetic field appeared to be the same strength as it is today, which tells us that the magnetic field of Earth has kind of like been a protection of our Earth for a long time. So I'm thinking without it, would we be here? I don't think so. All right.
Kind of sounding like Zach Bagans.
So, we are in summer, finally. We have first eukaryotes. This is 2,700 million years ago. On June 1st, we have a little leafy, which shows life. These are single-celled organisms. So these single-celled organisms have a nucleus and are an important step in the evolution of life, because eukaryotes led to all the complex multicellular organisms, which includes plants, fungi, and animals. Although we only have single-celled so far, without having these, we would not have any life farther down the road on our calendar. So if we stop and take a moment, we have first single-celled organisms. Look how long we have gone since the Earth was formed. It's a long time. So basically in the middle of our year, we're in summer, we're gonna keep moving. We have Earth is 2 billion years old on June 9th, and that is about 1 week after the first eukaryotes. And then we get into June 17th, a little later in the month, we have atmospheric oxygen growing to 1 to 2% at 2.5 billion years ago, or 2,500 million years ago. And this can be considered the Great Oxidation Event because the Earth's oxygen levels increased, which allowed our planet to become more habitable. Okay, we're going to go down a little bit more to our last event in June. We have the oldest evidence of a snowball Earth, which is 2.4 billion years ago. Think about a snowball Earth. We can kind of compare this to the movie Ice Age. So if you have seen Ice Age, Dawn of the Dinosaurs, the big mammoth, Sid the sloth, their whole planet was basically a bunch of ice. And that's kind of what a snowball Earth is. That's when our Earth was completely covered in snow. I'm not saying that Sid the sloth or mammoths were roaming around the Earth at this time, but we can kind of get an idea of what the Earth looked like as like all ice from that movie. This event shows the oldest evidence of a snowball Earth, and some scientists say that the event of a snowball Earth triggered changes in the evolution of cells that have been present on Earth so far. So without that snowball Earth, we probably wouldn't have life moving on as it has. July 1st, we're at 2,325 million years ago. Nothing much going on in July. But as we hit August, we're jumping to 1,930 million years ago. And then if we skidly on that a little bit farther, we have the formation of the supercontinent Columbia. This is a personal event I chose to put in my calendar. We are on August 11th. You can see that nice and good. We're at 1,800 million years ago, or 1.8 billion years ago. I chose to include this event in my calendar because it gives us an idea of how Pangaea formed later on. We'll get into that a little bit later because Pangaea has not formed yet, but we have Columbia forming, which kind of all shrunk together, like moved closer together. This is important, and it shows that our Earth was able to push bodies of land closer and even fuse them together into one whole. I think it is cool knowing that not all the continents were together, or there were things going on with our continents before Pangea, because I haven't heard of anything besides Pangea. So I thought this would be a cool thing to add, knowing that Columbia was moving before Pangea. All right. August 27th, we have the Earth is 3 billion years old. It's pretty old. We're getting closer to the end of our year. Okay, September 1st. 1,535 million years ago. Nothing really going on. So we still have life, just a little bit of life, single cell organisms. But after basically the summer and getting into fall, we have not seen any really life changes. Until we get into October. Yeah, October 22nd, which is 900 million years ago. We have multicellular life. So these are not single cell organisms, they're multicellular organisms. These still have a nucleus. November 1st, 775 million years ago. We're gonna go about a week later to get to November 10th, week in like 3 days. And we have our most recent snowball Earth. Again, kind of think of like Ice Age, but without all the animals. And we kind of get an idea of how cold or what it was like to be on a snowball Earth. It was covered in large, thick layers of ice and snow, which allowed the atmosphere to separate from the oceans. So we have like two different things going on. Earth is 4 billion years old. We're at November 14th. 4 days later. All right. We're 600 million years ago at that point. Okay, we have another life symbol, little leaf. We have the Cambrian explosion of life, which took place 542 million years ago on November 19th. And we're getting a little closer to Thanksgiving on our cosmic calendar, like if we kind of think about it to make these more realistic to understand. So this was like a rapid burst of evolution. We can guess that since the Earth was going through a new dawn with new animals due to this Cambrian explosion, we can also try and think of another planet. What's out there? What's going on with Venus? I don't know, but let's try and guess based on what we have with Earth. We can guess that since the Earth was going through a new dawn with new animals and living things, that Venus may have also been going through these things. But unfortunately, oceans started to evaporate on Venus, so they didn't get to sustain their life. They mostly just died off a little later on. Okay. We have the first fish on Earth 480 million years ago, November 24th. Less than a week after the Cambrian explosion. And these fish were able to quickly diversify due to that explosion of life about a week earlier. Then we get to November 27th. 3 days later, we have the end Ordovician mass extinction. So 85, we see the little percent of the species gone. And we see the skull and crossbones. We're at 440 million years ago, November 27th. So that's kind of crazy. This is our first extinction that we've had, and 85% are gone. All right? To November 29th, we have the first arthropods on land. We're at 420 million years ago. We see the little leaf, so we have a new form of life. We also have, about a day later, atmospheric oxygen is nearing our present level. And I believe that due to that, our first forests started to emerge. I'm not saying they were huge forests, but we see groups of trees kind of like starting to emerge, and I wouldn't say they're the trees that we see today. If we think of any dinosaur movies, you know how like that period they have the big like hanging like leaves. I'll insert some photos so you guys can see. But that's what we have going on. We have our first forest starting to develop 390 million years ago. I believe that was due to the atmospheric oxygen nearing present level. Okay, towards the end of our year, we're at December. We have 3 events going on right here. We have on December 2nd, we get our first vertebrates on land, which is about 375 million years ago. And then we get into the late Devonian mass extinction. So we get our first vertebrates, and then we get another mass extinction. As you can see, the skull and crossbones. This is when 75% of the species were wiped out. And then on December 3rd, these all happen right around the same time. So a day later, we get our first seed plants, 360 million years ago on December 3rd, with our little leaf in the corner. Okay, we can move on to about a week later, we get supercontinent Pangea forms. We're at 280 million years ago on December 10th. All right, this is how I'm gonna kind of explain this one to you guys. Have you ever thrown pieces of bread or styrofoam into a lake or a little pond for little duckies? Well, if you do, you can notice that the pieces will start to float and kind of like get pushed together. They'll clump together eventually because they're getting nice and soft at the bottom. Well, with this event, multiple continents are kind of floating on the earth and in our oceans, and then they're getting pulled together and formed and fused into one big clump, which is what gave us Pangea. Okay. Although it took millions of years for them to clump together, not like the bread or styrofoam. Alright. Then on December 12th, we get the end Permian mass extinction. This is 250 million years ago on December 12th. 95% of our species are gone. Skull and crossbones, as you can see. And then, who cares about the extinction? We got first dinosaurs and mammals, because we got more life. Which is 220 million years ago. We're on December 15th. We're getting through the last month of our year. And if we kind of think, well, dinosaurs were alive like a long time ago. Well, I mean, it's kind of not that far from the end of our calendar, and humans have not even emerged yet. So it's kind of a short distance if we look at it on our cosmic calendar. One day later, after early dinosaurs and mammals were on Earth, we get the end Triassic mass extinction, which wiped off 80% of our species. It happened 200 million years ago. These species got wiped off the Earth due to like climate change or volcanic eruptions or activity, and basically we have 80% less of our dinosaurs and mammals. And then we also get supercontinent Pangea breaking apart. So we just had it form, now it's kind of separating, and that was 200 million years ago. And we're only on December 16th. We still got a little bit left to go in December. Okay, we get another new life form. We have our earliest flowering plants. Have you ever planted seeds in the beginning of summer and had them bloom a few weeks later or even like a month later? Well, here we have the earliest flowering plants on Earth. We are on December 22nd, and we are about 130 million years ago. We are now able to see small flowers around this time, and some are even blooming. Okay, December 26th, we got the end creationist mass extinction. 75% of species are gone. 66 million years ago, that's not that long. We only have a few more events to go. And this happened about 4 days after our first flowering plants. About a day later, after the end creationist mass extinction, we get early primates. Primates are like monkeys. You see they got a big tail. This was 60 million years ago. We're on December 27th, about 5:44 in the morning. Here we are on December 29th. We have formation of the Nile River. It's the beginning of the formation. So we're not seeing the large river that we see today, but they're starting to be little creeks and cracks of water that will eventually start to form into the long river that supplied Egypt. I chose to put this on my calendar because Egypt is just very interesting and very mysterious to me. And being able to add a vital life source from Egypt on my calendar sounded pretty interesting to me. We're on the last day of the year, December 31st. We have the Grand Canyon starting to form, which is about 6 million years ago. We're at 12:30 in the afternoon, and then a few hours later, we have the first hominids, which is 5.2 million years ago. And then we also get the first modern Homo sapiens, which was 150,000 years ago, but we're only later in the day, the same day. We got this going on. We're about like 20 minutes away from midnight. And then we get like 10 minutes later, we see that humans nearly go extinct. About 99% died of the population. 99% of the population died. And people are saying that they went extinct due to climate changing and cooling and drought and the volcanic eruptions. And then on our last event of our calendar, we have ancient Greek astronomers, which was only 2,000 years ago. Doesn't seem that long if we consider how far we have gone. The first ancient Greek astronomers allowed our space and our planet to be discovered, because without them we wouldn't know any of this stuff that has been going on. We're at 11:59 p.m. about to be New Year's. Before I leave you here today, I want to mention that if we were to discover a new Earth-like planet orbiting 1 AU from the Sun-like star, and astronomers believe it to be only 1 billion years old, we can use our cosmic calendar to guess how it may have evolved and what it may be like today. Since we have all of these events of what Earth has gone through, we can kind of compare that to another planet in our solar system that has conditions like Earth. If we say that this planet is 3 billion years old, we can compare it to Earth at 3 billion years old, and we can guess that there are still no signs of multicellular life because there's no multicellular life on Earth. But in a few million years, that new Earth-like planet may have single-celled organisms with nucleuses, and if they already have those, they could develop into more diverse organisms. Okay, we are at the end of our calendar. We've gone all the way back to the beginning of the 200 meters. We started at 200 meters, so we've slowly made our way down. I hope you get a more understanding of all the events that have taken place on our Earth and how our Earth was created and how it evolved over time.